Hello and welcome to this second video on the NumPy function. In this video I will be starting on the second Jupyter notebook, in which I will be talking about selection using indexing of the array. Then I will talk about bracket indexing, and then I will talk about broadcasting, and then I will finish by selection. Then I will try to cover also the third Jupyter notebook, which is actually on some of the operations that we can apply on these arrays, which we have seen how we create and how we manipulate. And then we will use array functions to try and execute some operations on the arrays that we have created. So let's not waste any more time, and let's go and see how we do this selection by index. And if you remember in the crash course on Python, which I have introduced earlier, I have actually showed you how we use indexing to access lists and dictionaries and strings. So this is actually going to be applied here again. Therefore, it's very important for you, if you haven't seen that series of videos on the basic operations of Python, to go back and see it, because it will help you to reinforce your understanding when you come to this very important library. So I will start this Jupyter notebook by importing NumPy, because if I don't import it, then I will not be able to use any of the functionalities that are actually there. For example, if you see, I'm trying to create an array in this cell from a list, and I want to actually access this array by some of the methods which I explain in a second. But let's just try and run this, and you will see it will not run because I have already imported NumPy. So let's say I haven't imported NumPy. Let's open this one. I didn't actually run NumPy here, and I want to actually create two arrays and just print these. If I try to run this, you see, because NumPy is already included in installed, and it's actually included in the previous run. So therefore, I apologize, but you need to understand that we need to import NumPy for us to actually work. So if I stop the kernel here and restart and clear all outputs, now I don't have a run for NumPy. Can you see, if I try to run this now, it actually should give me an error, and it says NumPy is not defined, and that's because we haven't actually executed or we have this command here, which actually importing NumPy. So once it's imported, then I can actually start using the functionality which are available. So if I run this now and then come back to run this cell here, it should run without a problem, because now NumPy is available for us. Now what did we do in this here? I'm trying to create a one-dimensional array, and I used the function array, and I passed to it a list of 1 to 5, and it will create for me the one-dimensional array in here, as you can see here. Then I want to access the elements within that array. So I will use the same methodology of index accessing that I introduced in the basic Python course. And in here, I am actually calling the array that we have already created here, and I want to access index number 2, which means I am actually trying to access this value here, which is 3, and because it's index 0, 1, and 2. So by passing that individually there, I am actually only accessing index number 2. So if I run this, it actually gives me element at index number 2 is 3, which is true, is that one there. Now, if I uncomment this and I say I want to access index number 1 to 5, up to 5, that means it will actually include the content of index 1, 2, 3, and 4. It will not include 5 up to 5. So you need to remember this, and I talked about it a lot in that introduction course on Python. So if I run this, then it should tell me the content of index 1 to index 4 are 2, 3, 4, and 5. Okay, so that's how it is, 2, 3, 4, and 5. So it worked fine for me because that's 0, 1, 2, 3, 4. Now, if I change this up to 4, it should not include the last one. Okay, up to 4, it will not include the last one. So now it actually included 1, 2, 3, and 4 is not included. And we are talking about 1, 2, and 3. Okay, and that's what I have here. Now, if I don't want to limit this, then all I have to do is just remove this, and I say start by accessing the array's index from 1 up to the end. And if I run this, now it should actually give me the rest, because I could have there 6, sorry, it's double space here, and 7, and as many more as I want. Now if I run it, can you see it's 1, 2, 3, 4, 5, 6. So it's from 0 to 6, and it actually starting from 1 beyond. Now if I want to access it in a different way, where I want to access from 0, then I will actually to the end, I will say 0 to the end, and it will actually go and give me that. And it actually accessed all the indices in that array. So let's just keep that into 3 and or 4, sorry, and run this, and now you can see what it's actually done. Let's actually comment this also for the sake of the example. Then you can see what we are doing here. Okay. We can do the same for a two-dimensional array, and we can access by index again. So if I run this array here, we created a two-dimensional array, which is there, and then I wanted to access element in row 1, column 2, okay, which means it should be row 1, which is that, and I want index 2, which is that, okay, and I want to access to slice it, or to access second row, and I want everything in that second row. Then I can actually use this here. Let's just comment this here and just go through the first part, which is accessing first row and column 2 index, which is index 2 there. Okay, so if I run this, it actually gives me the array shape. This is the array, and the element that I am trying to access is actually this one, which is number 2. So I'm actually accessing this row, and I want index number 2. Therefore, I actually define index number 2 there, and it goes and accesses it for me. Now, if I run this again now, you can see that I have actually accessed slice second row, okay, and then I actually, which is this one here, the array, I'm actually calling this, and I want to access row 1, and then I want all the content of row 1. Okay, so I apply this slicing on it. I can say row 2 I want, and then I can actually bring the content of row 2. Can you see? It's actually gave me the content of row 2. If I want row 0, then I will say row 0, and I will apply this slicing which we applied earlier here to it. And I asked it to give me everything. I can say give me up to 2. Let's try this and see what will give me. It actually gave me 2. If I want to actually just access 0 and nothing else, it will actually just give me the first index. So it's row 1 index 0. Okay, now if I want to bring this back, and I can say all the row as it started from the beginning, and I can select any row that I want. And if it's the second, then I will say that. But to keep the example correct. Okay, so we can use conditional indexing, and you know the condition that you want something to be greater than 3 or less than 3, or whatever the condition you want. So conditional index is saying here you want the indices that are greater than 3. Okay, so and select items which is in one-dimensional array, which we have already created the one-dimensional array here. Okay, so we are accessing this array which is created here, this array here. We are accessing that here. So I want everything greater than 3. It's a single dimensional array. So it will take all the indices that are actually 3, 4, 5, whatever it is we have in that array. Okay, and I can select the element and I can pass them into a new dimensional array which we are creating. So if I run this now, you will see that actually this is the original array, and this is now the array which is greater than 3. So it actually have 4, 5, 6, and 7. So I can actually take an array and create a different array from that by putting some condition and creating under that condition a new array. And that's what we have done in this case. Okay, so I can also use indexing where I can change the indexing I am looking at. So let's see, in this case you can see the original array is as such, but I want to select element with a slice with some indices. Okay, so what did I do? I actually says indices selected are 0, 2, and 4, and that's all I want to create the new array with. And I can pass these indices to that array which we created earlier, which is 1 to 7. So I'm only going to select 0, 2, and 4. So I'm talking about just selected indices in this case, and these indices are 0, 2, and 4, and I will create a new array with these indices. So if I run this, then it should give me the select. So if I change this to make it 6 and 2 and 4, and I run it, it actually changed it. It actually brought this. So the order doesn't really matter how I want this to be actually created. So I can change the order as I want. So let's bring that back to how it was in the example. Okay, let's see. We have to update value using indices. So if I have an array already created and I want to change some values within the array, I want to exchange one value for another. We've seen that in the introduction videos on Python, where we took lists and we changed the values within lists, and we took dictionaries and we changed the values for keys within dictionaries. and we selected it based on keys or based on indices. It doesn't really matter when we're doing that for the dictionaries. In here, we are actually going to change values based on the location of that value within the array, the index of that component in the array or sample. The first thing, I want to actually use the same array that we have before, and I want to actually exchange the content of index 0. I want to replace it by 10, and I want to take index 1, row 1 of index 1, and I want to replace it by 99. So two of these arrays are actually created earlier. So this is array 2 and this is array 1. Okay, so remember these, and now I can actually come and execute my my cell. And if I run this cell, you can see now I have actually changed the content of the array. In the one-dimensional, I introduce 10 in place of 1, and in the second, I actually replace by 99, which is the first row, and the second index, which is 0, 1. Okay, so that's how we actually access components within arrays. Okay, let's look at bracket indexing. And this bracket indexing, we will select brackets within an array, and we can manipulate the content of these brackets. And we will use indexing. So brackets indexing for this case, because we know that brackets are actually index 1, index 0, index 1, index 2, and 3, and so on. So let's actually create an array, a single dimensional array here, as we did before, and a second dimensional array maybe later on. So let's see, we have a single dimensional array, and then I want to access that dimensional array at index 0, or I want to access it from 1 to 4. And you can see we can access this because we've seen it earlier. I gave an example of that in this video. Now I have a two-dimensional array, and as you can see, I have a number of listed lists, and I will convert this to two-dimensional array. And each row will come as a bracket in this case, and I should be able to access that. So let's see. If I run this, I have the matrix that's created from these list of nested lists, and then I actually wanted the element in column 2, and what is the element in column 2 in here? I have actually said I wanted column 2, and I wanted I wanted column 1, and I wanted the actual index is 2. So therefore it should give me that. So I went to the row, which is second row, and I want the second index, which is there, which is 0, 1, and 2. So it actually gave me the 6. And then I wanted to slice that, and I wanted to read it from 0 and beyond. So it actually reads that for me. It actually took row 0 and it read all the actual row. Or I can take the two-dimensional array, and I can read everything in row, which is actually in column 1. Okay, so I'm actually looking at column 1, and I'm actually reading everything in column 1, which would be 2, 5, and 8. So let's run this and see. It actually gives me that what I wanted. If I wanted to actually slice that, I wanted everything in row 1, I can actually change that to row 2, and let's see what happens here. It actually gave me everything in row 2, which is actually 3, 6, and 9. And if I want it in 0, then I will actually change that to 0. and if I run it, then it actually gave me 1, 4, and 7. So therefore, you need to play with this. You need to create something and play with it and see if you understand the logic. But it's very simple, as you can see. Now we can use conditional bracket indexing, where again I use a condition greater than 3 or whatever. So I have a one-dimensional array that we created earlier, and I want to actually select all the components which are at index greater than 3. So if I run this, I will create a new, this is the original, and this is the actual selected indices array. Now we use, again, fancy, we supply it with some indices that I want to create a new array with the content of particular indices within my original array. So in this case is 0, 2, and 4. So if I run this, this should actually, this is the original, this is 0 is there, 2 is there, and 4 is there, because I have 0, 2, and 4. Therefore it took 0, 2, and 4, and it actually entered them and created a new array with these values. Now, broadcasting is a function that we always use, and it's actually enables us to carry out element operations, and it allows us to do operation on different shape arrays, and that's very important, and you will see that it's actually important once we are working in machine learning and we are trying to create some machine learning algorithm, that we will use this actual array function quite a lot. Now let's see, we create a two-dimensional array from a nested list. Excuse me. And then I will actually go and broadcast this, and by adding a 5 to it. So let's see how we do that. So we have, can you see this here? It's two-dimensional. I took this list and created the two-dimensional array. Then as a result of the scalar broadcasting, adding 5. So now what I've done, I took every entry in that array and I added 5 to it. Okay, and I use the broadcast function, so it will read and then create the array with whatever logic that we have actually passed to it. So if I change this into 3, so it will actually create that with the addition of 3 to it. So it's up to you what you want to do here, and you can play with the logic here. Instead of actually plus, you can say -3, and then you can create the array with different values, or you can say multiply by whatever value you want. You can multiply it by 3, you can run that, and you can see the result is actually coming quite nicely to the way you want. So let's just bring it to the what the example says, plus, and it's 5. Okay, because that's what the print statement says. So I just want to make it correct for you. But when you are actually trying to code this, you should play with this logic and see if it actually works for everything that you want. Now we can create a two-dimensional array, and then we can broadcast by adding a one-dimensional array to a two-dimensional array and see how it actually works, because we have two different dimensionality here, so we can actually bring in this array, and we can actually add them together. So it's a nice way of actually carrying out the addition of these two arrays together. So let's run this and create these arrays and then add them together, and you can see I have two-dimensional array and I have one-dimensional array, and then I have the broadcasted array, which is actually taking this second dimension and adds the one-dimensional to it. It's 1 plus 10 plus 1, 11. 20 plus 2 is 22. 30 plus 3 is 33. Then 10 plus 4 is 14. 20 plus 5 is 25. And 30 plus 6 is 36. And we have a new array, and it's a nice actual way of carrying out this operation. So it's a very powerful function, and it can be very, very useful for you to carry out some array operation using this broadcast, and then assign this broadcast into a variable, and then utilize that variable to do something else. So now let's see the selection. We have actually done selection earlier on arrays, and I showed you how we can actually do this by single index or by slicing, and I am just repeating this to confirm that it's important for you to use. So I have a single dimensional array, and then I can actually do selection based on index that I want to do. So array greater than 2, then I create a new one and I select all the content, and we've seen example on that, but no harm in doing it again. So again, in here I want this two-dimensional array, and I want to actually access certain component of that dimensional array. I want it to access row 1, and I want it to access index 2. So it's the same example as we did before, just reaffirming, summarizing what we have done. And if you look at this one here, we use slicing. I want everything from 1 up to 4, and this way it will be actually a new array with the components that are actually starting 1 and up to 4. It will not include 4, it's just 3 there will be included. And the last one is the fancy indexing, where I am actually selecting individual index within the original array and creating a new array with this indexing. So this actually how easy it is. Now this comes to the end of this second Jupyter notebook, and you've seen, if you have watched the introduction videos on Python, you will see that actually these Jupyter notebooks are very simple and very easy to use, and the actual examples is diverse, and they actually show most of the operation that we will be using once we are actually working with machine learning. So let me move now into this third Jupyter notebooks, and let's see if we can actually do some operations using the arrays that we are being introduced. And the first operation that I will do is the addition operation. So if I have two arrays, two one-dimensional arrays, and I want to add these arrays together, then I can actually do a simple operation by saying array 1 plus array 2, and it should actually do that for me without any problem. So these are the two arrays. Now I'm just adding them. I take the first element in each and I add it, then the second element, then the third element, and you add them, and it's not a problem. I can do the same with actual subtraction, and it should give me the result of this subtraction. Then I can actually do the actual multiplication, where we're actually doing a multiplication. It will take this times this, and this times this, and this times this, and it should return it for me. So it's very simple when we are working with one-dimensional array. When we come to work with two-dimensional array, then it might become a little bit more interesting. So the multiplication also works without a problem, and it follows the same logic. The division is also the same. However, in the division, you need to understand that you will always have the result in a float format, not in an integer format. Okay? If I want to convert it to integer, then I need to specify how to convert it to integer, and I can convert it to integer. So let's see. As you can see now, it works, and I have actually divided array 2 by array 1, it will take the 0 index array and it will of the first array, and it will divide it by the second array's 0 index location, and so on until we finish the array. If I want to create an array which contains the square of an array, then all I need to do is just call the array and then do the actual square of it by using the double asterisk, as you can see here, and just put 2. If I wanted to the cube or the quadratic of that, then I can use exactly the same logic, and if I run this, you will see that it actually gives me the result without a problem. Now, if we can define what we mean by universal function, it's a function that operates element-wise, okay, on arrays, meaning they perform operation on each element of an array independently, which means it's a universal function. And that's what we are going to try and use now, which is very important in numerical operations within NumPy. So let's see and create this. If I run this, what am I doing? I'm actually creating the array by passing this list, and that's the array. Then I am actually want to call the function square, and that will what will do, it will actually read that array, and it will take individual component, and it will actually do the root square of that array. So it actually took the 4, and the root of that is 2. Then 9, and the root for that is 3, and 4 for the 16, and so on. And it's actually nice way of actually finding the root square of an array. So we can actually perform this operation on arrays without a problem. The next one, we want to calculate the exponential of each element, and that's easy. We have a function called expo, and in here I will pass to that the array, and it should give me individual exponential for each component within the array itself, and therefore if I run this, it should actually give me the values of the exponential, which is e to the power, this is the original, I'm using array which is called AR, which is here 4, 9, and 16. Okay, and I'm taking the exponential of each element. So 4 is actually 5.45 e to the power 1, and which is multiplied by 10 to the power 1, and then 8.1 multiplied by 10 to the power 3, and so on. So it actually works, and it's a nice way of finding the exponential of values, because if we want to actually calculate that and write the code to do the calculation for us, it could be a lengthy process. Therefore, it's easier than defining a function and then call the function and pass the values. In this case, we have an array, we call this method, this function on it, and it actually does the calculation, and we know this function is available in the library itself, so it doesn't cause us any problems. Now, the next thing that I want to do is to actually calculate the sign, okay, and in there all we have to do is just use the function sign, and we pass the angles to that. So if I have an array called angles, and what do? I have passed these parameters, which is 0, and then I actually call the NumPy of I divided by 2, and then NumPy itself. So pi by 2 and pi, and I call this from the actual library in NumPy itself. So I call pi and over 2 and pi. So these are the three angles, 0, 90 and 180, and I want to calculate the sine for these. So if I call the function sine and I pass these angles to it, so I created this array automatically. And if I want to print the angles, it should actually give me the angles, the original angles, and I can actually print that. So print and let's see. Now I actually have the angles 0, 1.57 and 3.14. So if I excuse me, if now I pass these to the sine function, then it should actually give me these an array with all these angles. So once these 0 is there, you can see it's actually 0, 1.5, it's actually 1, and then 3.14, then it's actually the pi, because pi is 3.14, the angle of that pi, and this is over 2, so the division of that over 2 will give me this. And when I apply the sine on them, these are the values that I will get. So the sine of 90 is 1, and the sine of 180, which is the pi, is 1.2 to the power of 10 times 10 to the minus 16. So this is how it works. Calculating cosine is exactly the same. We already calculated or created the array angles, and we just pass that to the function cosine from the library NumPy, and it should give us the values, which are, as you can see there. So let's run this to make sure that it's actually working. And if I want to call a function sum, then it should actually give me the sum of these elements. So I have the array R, and if I return sum, and it should give me the sum of the elements which are there originally in the array. So I can print array also here. Just to verify that this is correct. And let's run this, and it's actually 4, 16, and 9 and 16. And if you add them together, it should actually give you the values. Okay, now calculating the mean of all elements in the array. Now mean is something that's very important, and we will be using a lot, because when we are optimizing, we are actually optimizing for the mean square error, and we will be using that quite a lot. We need to calculate the mean, and we need to carry out some operation on that, or the standard square error is something that I will introduce later on. It's not something for actually this lecture, but the mean is very easy to do. We sum all the components and we divide them by the number of components. So the function is simple and easy enough to use. So it's actually, we have 29 and we have 3. So you divide 29 by 3 and it should give you the mean of this array. So as you can see, it's a nice way of actually doing that. Maximum and minimum, we already seen how to actually find the maximum and minimum. We just use the max and the min. And if I want to find the index of the maximum and the minimum, then I will use argmax and argmin, and they should actually give us that. So this actually brings us to the end of this introduction on NumPy. I will be preparing, or I have already prepared, an exercise for you, which you will need, which I will also upload to the channel, and you will see in here what I have done. I have actually asked you to do certain operations using arrays, and when you see import NumPy as MP, and you should know how to import that from carrying out the work, and I explained that it will not work the library NumPy will not be running without importing the actual library as something, and I call it as NP. Then you need to create an array, create an array of 10 elements, array of 10 fives, and create an array of 10 to 50, then different simple things, and then use NumPy to generate arrays of 25 numbers. And you should be able to remember how to do that because you already have enough information explained to you there. Then I want you to access and select components from an array based on the indexes, and then I want you to actually do some operations, okay, on arrays. So this is a simple exercise that you can go through, and I will leave this for about a week, and then I will supply you with the solution, and then you can look at your solution that you have tried, and you can look at the solution which I supply you, and you can see if you have errors, then you can correct it. However, please remember, for everything that we are doing here, if you have a particular problem on some code that you are working on and you have questions, please post your question to me in the comments, and I will be able to communicate with you directly, and I will help you to solve your problem. This is something that you need to understand, that I am here to provide you with help whenever you need this help. This brings us to the end of this video. In the next video series, I will be talking about the library pandas, and I will show you how we can actually use pandas for our benefit in machine learning and